Hello everyone. So this video will be for the revision. It's a revision for the finals. I'll start with parabolas. Two worksheets are attached with these videos. Um, so I already had some of your questions, but I'm not going through them until we start with the basics first, and then we'll go with solving these worksheets and along with your questions. So first, before we start solving parabolas, let's just revise the idea of parabolas and um, the formulas that we're going to be using. Also, what is the meaning of the parameters that we have or the variables that we're having. Also, we're going to remember that we have two types of parabolas. Let's start with that. Okay, so let's just start with the two types of parabolas. We have a vertical parabola, let's do it here, that's V, and we have a horizontal parabola. Now, how can we remember this? A vertical parabola, how does it look like? Just going to put very small here. Just you can use this later on as a cheat sheet for the exam. Here, a vertical parabola has a horizontal directrix. Now, a horizontal directrix means it's going to be parallel to the x-axis. So the vertical parabola either looks up or down. I remember one of the students, one of you told me that so they don't they don't mix up between the vertical and horizontal. They usually think of the vertical parabola as a plate of food, and the directrix is the distance from the table to to this plate. It's an idea that you can use, but you have your own way of describing this. Anyway, for the horizontal parabola, a horizontal parabola will have a vertical directrix, which means the directrix is like a wall instead of a table. So it's going to be looking like this, which means it's parallel to the y-axis. Now, a horizontal parabola will be looking like this or like this for now. Okay, so it's either facing the right side or the left side. Okay, the vertical facing up and facing down. Now, also to remember, why did I write with these two small graphs? Because this will make you remember easily the formulas. We have two different formulas. We have the first one, which is for the vertical, that is x minus h, which is the parameter that we always use for the amount shifted in the x-axis, squared equals 4p. We will be mentioning what is p is later. And then we have y minus k, which is also a parameter that we always used in this book to describe the shifts happen in the y-axis. So the shifts happen up and down. Now, by common sense, when you look at this, let's write the other one so we can talk about common sense. Now here we have y minus k squared equals 4p, and then here instead of y we have x minus the parameter attached with it, which is h. Now, by common sense, how can I know if I gave you this in the exam and I asked you if this is a vertical or horizontal? Like, you don't have to memorize this, you have to understand. Now here, the square, you always have to see where this power, which is the square power, is raised on. Is it on the y or is it on x? If it's in the x, that means every single time you have a value in y, you'll be having two values in x because there's a square on the x. So every single time, so here for example, if we have this point in the y, in the other side will be facing 2 points in the x, 1 point in the y, 2 points in the x. Here as well, if it's facing down, 1 point in the y, 2 points in the x, 1 point in the y, 2 points in the x. So this shows us, because the square here is put on the bracket that contains x, that means it's a vertical parabola, where this is a vice versa, but with the same concept. Here we have y, so every single time we have one value in x, we're going, it faces it with two values in y. So here, for example, if this is one value in x, two values in y, one value in x, two values in y, which also can be described in another way. A horizontal parabola is never a function. It's not a function, because here when it doesn't go with the definition of a function, because every single time we have a value in x, uh, here for example, every single time you have a value in y, there are two values in x, but every single time you have a value in x, there's only and one only value in y. But here you don't. Even if you tried doing the vertical line test, if you did the vertical line test here, you'll get 2 points, which means this is not a function. So a horizontal parabola is not a function. A vertical parabola is a function. Okay, now let's go to the meaning of these parameters. We already mentioned h, which is the amount shifted in the x-axis, k, which is the amount shifted in the y-axis, p, which represent the distance between the directrix and the parabola, and the vertex. Now, let's talk about these two meanings. Okay. Now, in any parabola, there is something called a focus point and a directrix. Okay. To call this graph a parabola, the distance between the directrix, which is the line that is opposite to the parabola itself, to the curve. So here, if this is our directrix and this is our focus point, the distance between the focus point right here and the vertex, which is the point where the graph starts from, is equal to the distance between the vertex and the directrix. When this is applied, when this is true, that means this is a parabola. If else, it's not a parabola. It's just a normal curve. It's something else, but not a parabola. A parabola has to have this, a a distance between a focus point and vertex equals to the distance between a vertex and the directrix. Now, this distance right here, which is between the focus point and the vertex, or the distance between the vertex and the directrix, is called P right here. Okay, we call this P. The details of this is already mentioned in a previous video. So if you still need to understand this, you need to check the video again, and then just send me your questions. Now, what else do we need? We already mentioned K, we already mentioned P. Okay. I'm not going to write everything written in the table because you already have it in the book. I'm going to use it only because I really don't want you to memorize it. So here, let's just go to the first sheet. It's written sheet number 1 for revision, parabolas. I'm just going to open it right here. By the way, this sheet is already attached with the answers, so you can use it when you're studying. Like, it has all the ideas needed. Here, I'm just going to move this. Now, the first example that we have says that y equals x squared plus 16x plus 71. The question says, use the information provided to write the vertex form equation of each parabola. So what we need here, we need a vertex form. Sometimes I don't ask you this question exactly. Sometimes I might say, find P, or find H, or find K. In this case, you need to change it into the vertex form. So it doesn't have to be a straightforward question like in this case. So we're just going to change it into the vertex form, which is this form. Basically, it's the same form, just with some simple change. I'll show it to you later, but just change it into this form. So to change this into the vertex form, we need to have y with its amount shifted in the in the y-axis, x with its amount shifted in the x-axis, which means every variable has to have a constant next to it. So we will be having two terms in each side, two terms, which means a term. We call them terms because they're separated by a plus or negative sign. So we'll be having y plus or negative a number, x plus a negative a number, and then we'll see if there's any powers included. So the first thing we need to do is we need to eliminate or get rid of the constant that we have here, which is 71. So what do? We're just going to change it or take it into the other side with an opposite sign. So we'll be having y minus 71, that is equal to x squared plus 16x. Okay. For now, some of you might think that this is k, which is incorrect. We still don't get k. We don't have k. So don't do this in the exam. So many of you did this in one of the quizzes, and I already told you this is not k, not yet. Now, what we can do here, we need to make x with a number, to make x plus a number or negative a number, we need to do something called completing the square, which is something that we already studied before. Now, to complete the square, we need to find first, I'm going to use a different color, we're going to find b over 2, where b is the coefficient of x, because this is a quadratic equation, and for any quadratic equation, the quadratic equation is in the form ax squared plus bx plus c. Okay, now when we have this is a quadratic equation. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Now we're going only to use b. So we need to find b over 2. This is the first step. B over 2, which is what? B here is 16, which is the coefficient of x. So we have 16 over 2, which is equal to 8. That's the first step. The second step that we do is we square it. Okay, so we need b over 2 squared. B over 2 squared, which means b over 2 squared, which means it's 8 squared, which means it's 64. Now, do you see this number here? What we need to do to this number, we're going to add it to both sides of the equation. So basically, we're not changing the equation, we're just trying to make it easier for us to change it into the vertex form. Now, we just add the 64 to both sides of the equation, and then we will have y minus 71 plus 64. That's the first point. And then we have x squared plus 16x plus 64. Okay, here, these are the constants that we added. So this becomes y minus, we have here 7, equals Now, we already have the form of completing the square. Now, how can we solve it, or how can we simplify it? We can do this by, first we take x, 1x, so we have here, we have x squared, we take just 1, that's the x, and then we take the sign of the term in the middle, so we take the sign of the coefficient of x, the original coefficient of x, which is plus. We're just going to put plus here, and then let's do this, and then we take the square root of 64, which means we're just going to go step back into here, which is 8. It's always b over 2, so we're going to write b over 2 here. So let's just write this and make a square, or just b over 2. Okay, so in here b over 2, which is 8, so we're going to write 8, and then we just put the bracket with the square here, because this is a complete square. A complete square, which means when you square this binomial, you get this quadratic form. Now, yeah, here we are. We did it. Now this is here. Look, we have y minus a number equals x plus 8 and squared. These two numbers represent, now 7 is k, 8 is h. Now the question is, we have a third parameter that we need, which is p. What is p here? Okay, to know what p is, we need to go back into this. Now, what is the thing that is squared in here? It is the x. So let's just put it in the same form, in the same look there. So I'm just going to swap these two, so it's going to becomes clearer for you. X plus 8 squared equals y minus 7. Now, in this form, we're supposed to have 4p. We're supposed to have the 4p multiplied by y minus k, so it's multiplied by y minus 7. Is there any coefficient in here multiplied by y minus 7? Yes, there is, which is 1. So 4p is equal to 1, which means p, which is the distance between the the vertex and the focus, or the vertex and the directrix, which is the same, is equal to 1 over 4. 1 over 4 units. Doesn't matter like which unit are you using when you're graphing, it's just 1 over 4. Okay, now this is number 1 in the worksheet. The same question, we have 12, 14 different equations. Please study all of them, work on all of them, and let me know if you have any questions. Okay, for now I'm just going to go to solve another one with an additional idea, which is having a common factor multiplied by it. Let's see. Okay, let's do number 9. Okay, it has a coefficient to it. Number 9. Okay. In 9, oh, no, this is easy for you to do because it's already there. We don't need to change anything. Okay, number 10. Okay, number 10, which is it says 6 x squared plus 12x plus y plus 13 equals 0. Okay, now the first part is to just move the y plus 3 into plus 3 into the other side of the equation. So we're just left with this so we can complete the square. Then we have 6x squared plus 12x equals, take these two into the other side, so it becomes minus y minus 13. Let's keep it this way for now. Now here we already have a common factor, because when we do the completing the square, we complete the square, we have to make the coefficient of x squared 1. So we need to take this common factor, whatever it is, even if there was fraction, even if this number is different, you need to take the coefficient of x squared as a common factor. In this case, the coefficient of x squared is 6. So we're going to put 6 here out, and then we have x squared plus what's left here, which is 2x, okay, plus, I'm keeping this empty so I can show you what to do. And then we have minus y minus 13 plus a number, which is what we're going to do using complete the square, just like the previous one. Now, to complete the square here, we need first to find b over 2, which is the 2 over 2, which is 1. So the square of it, which is also 1. So b over 2 squared is equal to 1. Now we already have the number that we're going to add to both sides. Now to add this number here, we just put it as is. So we have 6x squared plus 2x plus 1, okay, equals. Now the idea in here, in this example, we don't add 1 into the 13 onto the other side of the equation, because in fact, if this was like a scale, what you added to the left side of the scale is not 1, it's in fact 6 multiplied by 1, because you already have a number here multiplied by it, but it's not shown inside the bracket. So here you're going to have the whole number, which is 6 multiplied by 1, which is 6. So in here we're going to add 6, so we'll be having minus y minus 13 plus 6. Okay, now we have here, we're just going to solve this. So we will be having 6 here. We take 1x like we said before, and then we take the sign of the middle coefficient or the middle term, which is plus, and then we just take the square of this one, which is the b over 2 originally, which is 1. Okay, and then we put the square on top. Now it's equal to, here we have negative y negative 7. Okay, we're just going to make this again similar to what we have right here, what we did earlier. So we want this one here to be x plus 1 squared, that is equal to, we're going to take the negative as a common factor here, and instead of 6 we'll be having 1 over 6, and then y minus 7. Okay, even if you found this like I said before, the vertex form, in the vertex form it's usually y equals, it's always y equals, but in here it doesn't matter, because usually I'm not going just to ask you to change it into the vertex form. We usually need you to find one of these parameters, so it's just changing it into this form is just a way to find it. So again, here we already had k. Here, this is our k. This is the 4p, and this is h. The negative here shows you if it looks down or left, depending on if it's a horizontal or vertical. In this case, it's a vertical parabola, so it's going to look down because there is a negative sign in here. So to find p, here 4p is equal to 1 over 6 negative, which means that p is equal to negative 1 over 24 units. Okay, I hope this is clear enough for you. Please check the rest of the equations and let me know if you have any questions. I'll be posting another video, next video, which is for the next question in this, which is graphing, finding the directrix, focus point, and the vertex, and then we're going to go through the next worksheet, which is also attached with this video.